Alright. He's gonna email you.
He already know me, man.
I feel like this camera is right in my face.
Here you go, Sean.
This is perfect. I start rolling for you.
So let's get going. Let's talk about this. It's volume 2. Oh yeah, Sean. Volume 2 textbook. So grab one of these up here.
You want me to go and press start?
Huh? I already did. But thank you.
I could have did it for you, but
I appreciate it. Alright, so I want to talk about this one. There's a couple of small details I want to point out. I think for the most part, we recognized that if I were... Actually, I want to go ahead and look over here at what these two groups did. What did these two groups do to start to graph their inverse?
Linear.
Yeah, what line did they draw?
Oh, linear.
They drew y equals x, didn't they?
Yep.
Because at its core, when we, So, when we do an inverse, right? What creates an inverse function or an inverse relation? The inputs and outputs are what? The inputs and outputs aren't reflected. There was a T word.
Oh, transposed.
The inputs and outputs are transposed or switched, right? But what caused the inputs and outputs to transpose? It's what you were saying, Nate. A reflection across what? Y equals x. Guys, you cannot forget this concept. It is the foundation of everything we're doing. The inputs and outputs are being transposed because of reflection across y equals x. What I also want to point out is some of us did a decent job about thinking about what this inverse would look like, but we could have been more accurate. What is this point right here? 1, comma, 0. So with the reflection, what's it going to become?
-1.
No,
0,
1.
I would say, remember how it just transposes?
What?
It would be this point.
Switch.
The input and output just transpose. 1, 0 becomes 0, 1. This point right here is 2, 1.
So we went
So
to
it would just be 1 and 2.
Oh, you going up? I thought you was like going across.
Well, so you do to reflect across, right?
Okay.
So this point reflected across. This point, where is it? Oh yeah, that 0, 1 would become 1, 0. Right here we have 3, 4. What's 3, 4 going to become?
4, 3.
4, 3. That's off. I know that's off. 1, 2, 3. 1, 2, 3, 4. That's what I was looking for. Becomes 4, 3. Notice if it's on this side of the line, it reflects to the other side, so it'd be here. And so what shape do we get?
the same thing.
The same thing. What's that same thing? A
Parabola.
parabola, but that parabola is what?
Sideways.
Sideways, it's horizontal, right? So we want to recognize, is the inverse a function?
No.
No. So this, and so we need to be careful with our language. Because what I see some of us saying is, like right here, we say it's not a function. But what do you mean it's not a function? Because how many relations do I have here? 2, right? Is the first one the original a function?
Yes.
Yes, so we want to recognize y equals x minus 1 squared is a function, but it's not what?
It's not invertible.
It's not invertible. Right? What we have here is a function, but it is not invertible because when we reflect, the inverse is not a what?
Function.
Not a function, right? So this is a function, but not invertible because reflection across y equals x is not a function. Now I'm going to use this example to build up some more of our understanding for that section about invertible functions and finding inverse functions. Okay? So I'm going to use this example to help us build up our understanding of inverse functions. So I'm going to talk through a couple of things and we're going to look at the information from the book on this. So I do want y'all to notice this point that went to the right, when we reflected across y equals x, it didn't go to the right anymore, it went up. By the way, Caitlin, Julian, I mean, it's your choice what you do, what you wanna do, but I would turn those desks so it's easier to see the board. Make it easier to take notes, right? So what was to the right is now going up. Notice what was going to the right and up is now gonna go up and to the right. So we're still keeping similar directions, but what's happening to our X and Y? They're being
Transpose.
transposed, they're being switched, right?
Why is that on, why is the second one not function?
So what is a function? What is the definition of a function?
Input, output?
They got
So,
two outputs.
one input
Well, you do the line.
maps to one and only one output, okay?
Okay, so.
So like if you look right here, this point is 4, 3. But if you look right here, this is also 4, -1. Do you see how that input of 4 maps to what? -1, and it maps to 3. So that one input, does it map to only one output? No. Does that explain it? Now remember, we also checked it yesterday. I think this is what Yana was explaining to you using what test? Vertical line test, right? So if a vertical line hits more than one point, that means one input maps to more than one output, right? And so if it fails that vertical line test, if it hits more than one point, it is failing this definition. Does that make sense? Okay.
But it's still a function though.
No, no.
Well, this is, so the original is a function, right? But this reflection, is it a function?
No.
No.
Okay.
That make sense? That's why we said y equals x minus 1 squared is a function, but it is not invertible.
Hey, would it always
Its
be like
reflection
that?
is not a function. Say again.
Would it always be like that?
Well, I'm about to teach you how to make it invertible.
Hey, let me tell you something.
Oh, so you can get one of these questions where it's gonna be like, hey, well, change it to where it's actually a function.
Yeah, yeah. It's
Oh,
super easy.
great.
Yeah, yeah.
That's
Hey,
great.
hold up.
Everything easy to you. It ain't easy to us.
Back up. No. I promise you, what I'm about to show you makes it super simple.
You talked
Watch
about
this.
last time.
What was it? What was the last thing I told you that
I
for?
don't even remember.
Oh, yeah. Alright. I'm pretty sure it was. It was like the graphing imaginary numbers, I think, was the last thing where I was like, oh yeah, this is super simple. Was I wrong about graphing imaginary numbers being super simple? I was wrong.
You were super wrong.
Seriously? If I gave you this point, 3 minus I, and I asked you to graph it, what are you going to do to graph that?
Put on the 3.
Down, you say, what was the 3? Okay, so let's remember, the x-axis is the real, the y-axis is the imaginary.
Put the 3 on the X. Put the, yeah.
So, which direction?
Right down one.
Right.
Positive 3, so to the right 3 and?
Down 1.
Man, that seems super simple to me.
Hey.
Hey! Not everything's simple, but graphing imaginary number, super simple.
What was on that shit yesterday when you...
To make this invertible is actually pretty simple. Okay, so here's one thing I want to point out. I mentioned this yesterday. Remember, Yana talked about this vertical line here, right? Now, if I look at the original function, and I were to draw, I don't know, maybe a horizontal line.
That's about the test you do.
But when I reflect across y equals x, what is that horizontal line going to become? It's going to become a vertical line.
Oh, you can't do horizontal?
So a horizontal line test tells you if the function is invertible. Because this horizontal line is hitting how many points? 2. When I reflect, the vertical line is going to touch how many points? 2. So we can check this. So we check with the vertical line test, right? So if it's a function, we check with the vertical line test. But now, what we can do is we can use the horizontal line test to see if the function is what? Invertible. That's it.
Hey, Count, can you move your head?
And I'm gonna define that horizontal line test in a second more clearly, but that's it, right? Like you can use a horizontal line because when I reflect across y equals x, what's that horizontal line gonna become, Sean? It's gonna become a vertical line, right? And if it fails the vertical line test, it's not a function. So if it fails the horizontal line test, its inverse is not a function. That's it, right? So if you understand the vertical line test, you understand the horizontal line test. The horizontal line test just tells me about the inverse, the reflection across y equals x.
Hey, do you edit these?
Nope. Were you not here yesterday either? Are we like 20 minutes in the class? You just not telling me this?
I wasn't here yesterday either.
She's trying to pull a shoulder over there.
I wasn't here.
I wasn't here yesterday either.
Alright,
Hey, I ain't gonna be here during the enrichment. I gotta go to China.
okay.
You gotta go where?
To China.
So,
Come on, bro. Bro, you might got it.
horizontal line test.
You trying to look at the camera. Just be turns to right.
So, if a relation, actually I say if a horizontal line
8 days, yeah.
intersects a relation, how many times do we want that horizontal line to intersect the relation so that its inverse is a function?
Twice.
For it to be a function?
One,
If a horizontal line intersects a relation once, then the inverse is or is not?
Is.
Is.
What you mean, that's a relation? What is that?
Right here. So remember, functions are just special types of relations,
Right.
right? A function, I should say, is a relation where one input maps to one and only one output, right? If you have inputs and outputs, you have a relation. So if this horizontal line intersects the relation only once, its inverse is a function. Is that inverse a function now? Or is that intersecting the function once?
No,
No. So is its inverse a function?
no.
No. Not till last night.
Does that answer your question? Okay.
Are
you sure?
It's
It's right there. If a horizontal line intersects a relation once, then the inverse is a function. The implication behind that is, if more than once, then inverse is what?
inverted.
Invertible.
Wait, if the horizontal line intersects more than once, then the inverse is
Not a function.
not a function. Let's be careful. The original function is invertible or not. What I'm saying here is the inverse, right? So I'm saying the inverse is not a function. Or we could say the original is not invertible, right? So be careful with your language on that.
Hey, Mr. Kim,
This can go under the invertible function section,
you do got my paper on finish line.
right? Invertible functions and finding inverse functions.
Hey, let you know you get it, right?
Okay.
Oh, it's good. My.
We're going to see a lot of this information in the textbook soon, but by the way, not there, Kyson. That says features of inverse functions. We should still be in the invertible
Hey,
functions
Mr. Kim,
section.
I wrote my stuff anyway. I ain't like see.
Say again,
Yeah,
sir?
I wrote all my stuff.
That's fine. Just make a note of it. Because here's the thing I do want you to understand. I have it separated that way so that you know what major concept goes with those sets of notes. So maybe on the back side where you have that set of notes, write the major concept. Because we need to understand what it means to be invertible and how to find the inverse algebraically. That's why I grouped it together. Bryson, why are you being so creepy? Oh, I appreciate you.
Hey, what that for?
I'll see you
Bryce.
I'm guessing it's because it's Teacher Appreciation Week.
You gave Kim something?
Teacher? Maybe he appreciates you too.
Why did he run?
I said maybe. Alright, so let's continue here with a couple of details.
I hope
So,
that camera-
last details that I need you to see on this, actually, it looks like some of us are still writing. If you're still writing, keep going, see what questions you need to ask.
I
Mason, you
miss,
got all these
this
notes?
kid, I look, they
I don't
rain,
even see your prayer bottle
people,
out.
they rain and stuff.
Ain't nobody.
I ain't gonna eat. No, I can save my time. Just bring my emails actually right here.
I gotta talk to him, bro. I gotta be.
I'm teaching right now, you can ask me after class.
Everybody got nothing to eat.
Okay, now,
Hey, you don't talk.
I need you to pay attention to two things, two last things. One, so let's say that, I'm gonna build off what we just talked about. What we just discussed, right, was that a function, one input, actually, let's do this really quickly. We already said y equals x squared, that's not invertible, right?
Halfway wash their clothes.
Hey. Pay attention. So, what function am I drawing right now? Cubic, right, y equals x cubed. Is this one invertible?
Yeah.
So watch this, right? First off, it's a function, right? Vertical line test, does it pass the vertical line test?
Yes.
Okay, does it pass the horizontal line test?
Yes.
Yes, right?
Give me something to read.
It packed it
Tyson?
for predicting.
So is this function invertible?
Yes.
Why?
Because
Because it's going what?
vertical.
No, dude.
What, bro?
Tyson, we gotta engage in the conversation. Not asking about food, I appreciate that you're hungry, but take care of that before class,
Man,
right?
y'all hungry.
Look, it's a function because it passes the vertical line test, meaning one input maps to one and only one output. Horizontal line test, right? So I want you to think about that. Horizontal line's flipping things, right? So what we're saying here with the horizontal line test is also one output
You got this one.
maps to what? To one and only one input.
Yep.
You see how there's this whole idea of one-to-one going on a whole lot here? So, hey guys, pay attention to this. So, invertible functions are one-to-one functions. Okay? So, what do I mean by that? One-to-one, one input maps to one and only one output, but also one output is mapped from one and only one input,
Why y'all
right?
spill these over?
But I should say mapped from.
What do it smell like?
So, quite literally, it's one-to-one. One input maps to one and only one output, and one output is mapped from only one input. Nate, I noticed you're looking at something. What you looking at over there? The what?
Okay.
Oh wait, is that on the vocab sheet?
And the 500.
Oh, it's kind of important, right? Is invertible functions on there?
No.
You were not here when I
I
passed
see
it down.
radical function.
So really quickly, what vocab words do we see on this board right now? One-to-one functions. What else? Transpose is not up here, but have we talked about transpose? Yes.
Power function.
Say again. What functions?
Power function.
Is when those inputs and outputs switch.
Power
Power functions. Now we haven't talked about power functions today, but what do I mean by a power function?
function. Power.
So it is only x squared, or just x cubed, or just x to the fourth, just x raised to a power. If there's anything else with it, it's no longer a power function. But look up here, any other vocab terms that we have used? Invertible functions, anything else? Inverse of a function, that's somewhere.
Extraneous solution.
Inverse is a function. Isn't the horizontal line test on there? Or am I making that up?
You make
Make
it
it
up.
Well, horizontal line test helps us test if a function is what?
Features.
Well, invertible, but also one to one. Remember, so like, if it passes the vertical line test and it passes the horizontal line test, the function is
Function.
one to one, right?
Miss Kim,
Sir,
we on Tornado Watch. Why we here?
say again, sir?
We on
Dude, if it
Tornado
turns
Watch.
into a warning, they gotta send us home.
It's a watch, it ain't a warning, dude.
We need
Yeah. They don't win yet.
I'm finna make one, finna make
They need to sound no siren so I can go home.
Alabama, it's probably gonna happen.
So 1 to 1. One input maps to one output, and each output is mapped from one and only one input.
Yep, only one.
Got you, Mr. King.
Only uno.
So passes what to test? Vertical line test and horizontal line test.
Oh, yeah.
Vertical line test and horizontal line test, that's it.
Why you keep moving, bruh?
Well, I need to focus on that, not on me. I need to be able to see most of the board, right?
Hey, when you moved over, I moved with you, bro.
Hey, am I?
Hey guys, I need y'all to
You see me?
have these
Yeah.
notes right here. There's only gonna be one more thing and we're almost done with inverse functions. Just be a little bit of practice and one other concept.
I'm probably can see it,
Well,
Ken.
we're only talking about horizontal and vertical. Kyson, my man, let's wake up.
I don't think he's fit yet.
He's trying. I ain't letting him.
Julie said he gotta go to the hospital.
So what do you do all summer? Do you just practice math equations all summer?
I'll be taking classes at UA to
I would
try to
need-
become a better teacher. I am reading for the AP statistics exam.
Just Ken.
I am moving houses and setting up a new house. I'm actually leading professional development for a few math teachers.
Miss Kim.
I have 2 sessions or 3 sessions this summer. I have a few.
I wouldn't tell nobody
Sound
that.
like fun.
Don't tell nobody else that.
What?
Don't tell nobody else that.
Why?
Just tell them that you building a house. Don't tell them the rest of it.
The rest of it is.
Just tell them you moving into your house.
No, we're moving.
Just tell them you
We
moving
bought a
into your
house.
house. Don't say none all other stuff.
Why?
Yeah.
Because I just sound super nerdy?
Yes.
Hey guys, I got a secret for you that's not that secret. I am a giant nerd who loves to learn and wants other
Miss
people to
Ken, there ain't
learn.
no secret.
I literally said that.
Let me guess. You watched Star Wars from the first Star Wars to the last Star Wars?
Okay, first off, I'm not old enough for when the original Star Wars came out, but heck yeah.
Alright,
Anyway,
I
actually,
watched Star Wars
episode 7 through 9. So, anyways, getting back to that. Right here. We have to understand the vocabulary. If you don't understand the vocabulary, a lot of this gets really tough. But, you remember how you were earlier freaking out about, man, Mr. Kinney, I don't know that it's going to be easy to make a function, okay, or make this invertible. Well, here's all we have to do. We're going to restrict the domain. What is the domain of this current function?
Negative infinity to positive infinity.
The domain currently is negative infinity to positive infinity, which is why, does it pass the horizontal line test?
Yeah. No. Wait, what?
Does it pass the horizontal line test?
Yeah.
Remember, to pass the horizontal line test, we want that horizontal line to intersect a relation once, so the inverse is a function, right? Okay? So I want us to think about this. I want someone to come up here, just make a prediction, it doesn't have to be right. I want someone to come up here, and I want you to scratch out, like just kind of use a marker to scratch out part of this function to make it invertible.
Invertible? What you mean by invertible?
The
Well,
inverse is
we've been learning
a
about
what?
the whole time, Trey.
Bro.
It's the thing that makes it where it's actually a function.
Okay, so would this make it invertible? Now,
Yeah?
did you mean to continue it a little bit more?
Yeah, I did. But I think,
Where did you want to stop it?
like, at the one.
At the vertex?
Hey, he just stole
I want
mine.
y'all to look at this.
Facts.
I want you to look at this. Is that function now invertible?
Yes.
Oh, so all I have to do is restrict the domain from, what's my domain now?
One.
1
Positive infinity.
to infinity. Oh, my function's now invertible.
Miss
Trey, was
Ken.
that super hard?
Yeah.
Are you just trying to be obstinate?
Yeah.
Yeah.
Nice work.
So, please notice, listen, to make a function invertible, all I have to do is restrict the domain so that the function passes what? What does the function have to pass? It has to be 1 to 1, which means it's going to pass the horizontal line test and the vertical line test. Right? So if I want my function to be invertible, I have to restrict the domain so that it becomes 1 to 1. That's it. And notice what key point did council quit at? What key point did council quit shading?
The vertex.
The vertex, right?
On the
Once
five.
you get to the vertex,
Oh, yeah.
so starting at the vertex and going to the right is 1 to 1. Notice it is still the same function. What have I done though? Restrict the domain. So like I can actually type this into a calculator and tell the calculator to only graph 1 to infinity, and now the function's invertible. Okay? I can type this into the calculator and now the function's invertible. And I want us to look at what happens when I reflect across the line y equals x now. This 1, 0 still becomes 0, 1. But now I only have to the right. So this 2, 1 becomes 1, 2. 1, 2.
That's why I said.
And then this 3, 4 becomes 4, 3.
Yup.
Does that look at all familiar? That pink? Where did we see that yesterday?
Wait, explain it again.
Say again.
Can you explain the pink line again?
The pink curve or the pink line?
The pink curve.
Curve.
Right,
So
the number.
remember, this was the point 1, 0.
Mhm.
So when I transpose it for reflecting, it
Right.
becomes 0, 1.
Mhm.
This point 2, 1 will become what?
1, 2.
1, 2 when I transpose. And then this point right here of 3, 4 is going to become 4, 3. And I can keep doing that with all these points, right? And so notice, right, I now get this curve here. Notice, is this curve now a function?
Yeah.
Yeah. Remember how when I drew my horizontal parabola earlier, was it a function?
No.
No, but is it now?
Yes.
Yes, okay. Well, I wouldn't keep going, because remember how I restricted the domain, so I no longer have this left half? So now I'll no longer have the bottom half. Okay? Here's the last thing I want us to look at. I believe there's a section that says, oh yeah, top right still says finding inverse functions algebraically. If you need to, because you're out of room, put it in the bottom left corner. Okay? So this is inverses algebraically.
The thing I asked, are we doing line notes? Sorry, Rick.
Okay.
G. Willard.
Inverse.
Inverses algebraically.
This is how I was gonna be like set up.
Well, that's the function, right? Y equals x minus 1 squared,
Okay.
right? So, Janai, remind me of this. What happens to our inputs and outputs when we get an inverse? The question was, what happens to my inputs and outputs when I get an inverse?
They switch.
Transpose.
Let's use that better language. What is it? They transpose, right? So what's going to happen to my y and my x here?
Split.
They're going to transpose.
So they be.
What is?
Y minus 1 squared.
Oh.
Why zero?
See, I wasn't thinking like that, Miss King.
You see how the x and y transpose though?
Yes.
The inputs and outputs what?
Transpose.
Transpose, right? Okay, okay. But when I type an equation into the calculator, how do I want it to read? Y equals, right? So what do I need to do so that I get y equals? No. Look at the equation. What do I need to do? What do I need to do to get y equals?
Up.
How would I solve that? Can I use inverses to get to just the y? Alright, so Jacayla, remind me of this. What's happening to y first? The y that I want, what's happening to it?
What happened to education? I'm sorry.
Okay, so is the y squared before anything else? Remember, what's my order of operations? Parentheses, exponents, multiplication, division, addition, subtraction. So what was the first of those that we see up here? Parentheses. I gotta look at those parentheses first. So what's happening to y first? No. The order of operations. What's happening to y first? We already transposed it. Y is being subtracted by 1. What's happening after we subtract y by 1? It's being squared. Is anything else happening?
No.
So what do I need to do first to get to y, to undo that stuff? What's the inverse of a square?
Square.
A square root. Okay. The square root of a square, those cancel. Whatever I do to one side, I have to do to the other. Alright, we all good? Is this mathematically correct so far? I'm not forgetting anything? Well, remember when I took the square root, right? I don't need to group those anymore. I think we're forgetting something over here though. The what? Say it, Caleb. Positive and negative. I took the square root, didn't I? Technically. But, okay. So what was your question, Des? So when I look at it, it's already y minus 1. So what do I actually need to do? What do I need to do? Huh? Okay, so I want you to think about this, Des. What's negative 1 minus 1? Is it 0? That's negative 2, guys. Negative 1 minus 1. Think about a number line. 0, negative 1, negative 2. When I subtract, which direction do I go? Left. So if I subtract 1, hey, if I subtract 1, I get negative 2. But what do we want to get to?
0.
So what do I need to do to go to the right? Add. Remember, the inverse of subtraction is addition. That creates a 0. So now I have y equals positive, negative, square root of x plus 1. Yes? It means we have both a positive and a negative. So it'd be two different functions. So, Chandler, we did this with solving quadratics. If I have 5 plus or minus 3, that means it's 5 plus 3 and 5 minus 3. It literally is two different things of sorts. Yes, Julian? You still need to go?
What you gonna say that thing, brother? What you gonna say?
He's trying to go to the nerd for the vocab too. He gonna stay in the
So they was just trying to get out there.
We got a vocab test.
Hey,
One.
your last chapter. Oh, you told me no. Oh, Joe.
Alright. Hey guys, I'm almost done. I'm almost done, at least with this set of notes based on the bell ringer. Here's what I need us to notice. So if we're going to go inverses algebraically, what's the first thing we had to do? To go right from here to what we did in purple, what did we do?
Switch.
So if we switch our inputs and outputs, we're what?
Transpose.
Transpose, right? That's an inverse. So transpose, input, and output, right? Now I heard some of us saying, hey, we took a square root, and that's for this piece. But overall, what are we really doing when we took that square root? We're using what? Inverse what? Functions?
Operations.
Operations, right? We're using inverse operations. To solve for what?
X.
I already had what x was equal to. What was I solving for?
Y.
Y. Which one? Say it again. Well, if we're gonna, if you remember, x is my independent variable, y is my dependent variable. So I need my independent and my dependent depends upon this independent. So y equals. Okay, 8 to 1. What did I just tell counsel because of his question?
I was at the door. I don't know what you told me.
Actually, you were just talking across the room when I explained it to him, so you weren't paying attention. It wasn't that you were at the door. what council was asking was, he said, why are we solving for y? And the idea is that I need to solve for y because y is my output. And x is my input, right? So I need to solve for it so that x is my input, y is my output. And once I do that, I have my inverse function. Thank you, Ariane. All right. Now, we run into one issue when we do it that way.
I knew that though.
Good. No, not that good. So we cannot do the positive and negative at the same time. Notice, hey guys, notice right here, if I only do the positive square root of x, remember how when we restricted our domain, we only had the top half? So even though mathematically I technically need to do positive and negative, when I do an inverse function, do I do both the positive and the negative? Well, look at the if I do the positive and the negative,
It's not gonna work. It'll be invalid function.
is that a function? If I do the positive and the negative?
No.
No. Remember how we had to restrict our domain? Right? And so when we restricted our domain, we didn't have this left half, and if I don't have the left half, am I going to have the bottom half?
No.
No. So that's the last piece of this puzzle that I need us to recognize. Nope, that's not what I wanted. Okay? You're a G Willikers. Alright, the last piece of the puzzle is this. Can only have y equals a positive square root of x plus 1 for inverse function. Notice, quite literally, if I have a positive and a negative here, one input's going to have how many outputs?
2.
2, right? Is that a function if one input has 2 outputs? No. And so that's what we need to recognize here, is that even though mathematically I need the positive and the negative, to be an inverse function, can I have both? To have an inverse function, can I have both?
No.
Okay.
No.
You need to have those notes. That gets you through everything in the top half and even, actually it's just everything in the top half, but it's going to lead us into the majority of the bottom half. Say again? Yes.
Both. Yeah.
The top half is the majority of what we're learning. The bottom half is a little bit lighter.
I can't see from
You need glasses. Glasses?
Yeah.
How is a bad word?
So, I wear contacts.
We know.
Put some glasses on. Put some glasses on right quick. Did you look them up?
I have glasses. I just can't work out in the morning
Did
with
you look
glasses.
them up?
Huh?
Did you look them up?
Look what up?
Well, I told you to look up the one time in class.
I have no clue what you're
The
referring to.
professor, go look them up. Please look them up.
Like the basketball guy?
No.
Who?
He get active.
Tell me you're going.
I think you call you nutty professor.
No.
Say again.
You are okay.
No.
All of these functions are power functions.
We don't know what you're talking about.
I don't get no fuck.
Notice that this is based on Chandler's question. All of these are called power functions because it's literally just a variable raised to a power. Here, I would not call this a power function. Because of that -1, right? As soon as you add something to it, as soon as you what are called transformations, once you create transformations, it's no longer a power function. The power functions are just these. Okay, that's it.
Well, if I add raise to fifth.
No shit. Effective.
Power.
That'd be a power because there's no other transformations. Those parentheses don't change anything. All right, before we continue, what questions do you have?
You know, I got a bunch of questions.
I got a bunch.
Can we stop or
No.
or
my name's Counselor, I just wanna complain.
If we don't
My life's so hard.
review for next week.
Okay.
Wait, for review for next week, what if we don't have to review?
The one said he wouldn't know.
We'll cross that bridge when we get there, test on
We're almost there.
Alright, so really quickly, I just wanna point this out, because we should know a lot of these concepts now. Have we studied inverse of a function?
Breaking half.
One-to-one functions, power functions, radical functions. Hold on to that idea. Invertible functions,
Oh, bitch.
transposing, composition, features, yeah, haven't covered those three.
What is
Extraneous. We'll talk about it later today and maybe tomorrow. Identify the features of a function. What do I mean by the features of a function?
If it's an invertible function,
Domain, range, extrema,
In behavior.
in behavior, domain intervals of increase and decrease. Yes, Chandler. Maximum and minimum.
the things.
We'll talk about it again soon. Have we talked about determining if a relation is a function?
Yeah,
How about if a function is one-to-one?
yeah.
Okay? Have we talked about restricting the domain of a function to make it invertible? Have we done composing two functions?
Oh no.
No. Do we know how to determine if two functions are inverses graphically?
Yes.
How would we do that?
Vertical line test, horizontal line test.
That lets us know if it's if they are invertible. But I asked, hey guys, what do we know graphically about two functions if they're inverses? That's just to see if it's invertible. My question is, what has to be true when I get an inverse function? It
The
needs to.
composition.
Well, okay. Let me ask you a different way.
Yeah, bro. Now we know what you're talking about.
Could these be inverse functions? Why not?
Can't be.
Okay, sorry. Could they be inverses? Not necessarily inverse functions. Could these be inverses?
Yeah. No,
Nice.
no, not inverted. I'm waiting. What?
Hey guys,
Not inverted. Not inverted. What?
hey, we're not going back to our vocabulary.
Not invertible.
Listen, you're not listening to the vocabulary. The vocab is the key. What do you know about inverse functions or inverse relations? We need better language, not quite. Kyson, I can come collect that from you.
It transpose.
What transpose? The inputs and outputs what? Transpose. So could I check to see if these are inverses through looking at those points?
Yeah.
Yes.
Okay, but what causes those inputs and outputs to transpose?
The transposure.
Y equals X.
What about the line y equals x?
The transpose. Or, sorry, it reflects across that line.
Look guys, hey, when I ask, go on. When I ask if two functions are inverses graphically, what causes an inverse? A reflection across y equals x. Is this a reflection across y equals x?
No.
They're on the same side of the line, so could they be inverses?
Why you ain't drawing on the other side?
Because I would just to see that those would not be inverses. Okay? Now,
Yeah.
what about these functions?
Oh yeah. Yeah. That is right there. That is. No, that ain't it. That ain't it.
Why not?
Because it ain't what you call it.
Notice, well, it would be on the axis a little bit, but look, this might be the point 0, 1, right? So where should the vertex be over here? 1, 0. So would those be inverses?
Yes.
No.
Oh, no.
It needs to be somewhere like here, right? And so we need to recognize it has to, it can't just look like it, it has to actually be a reflection across
Yeah.
y equals
X.
x, right? And those inputs and outputs have to what? Transpose.
Go, Dave.
Guys.
Flip here.
Nigga don't want.
Leave him alone, already.
I just saw somebody was.
Leave him alone.
So-
I'm fine.
Look at that. Ain't no slim.
Hey, excuse me. Y'all still have to demonstrate your understanding tomorrow. Step up. Let's pay attention. I told y'all that yesterday.
On this stuff, like,
Then you come in on your time and take your test.
I came in yesterday, you didn't wanna get you.
And I told you to come in during PE. Come in during PE so that, yeah, come in during PE and take it. Alright. Can we graph the inverse of a function given graphically or tabularly? Excuse me. How would I graph the inverse of a function given graphically or tabularly? A reflection across
Leave him alone.
y equals x, or transpose those inputs and outputs, right? Both of those ideas together.
Yeah, I like that one.
Alright, so, and then we haven't solved the equation, yeah, I just showed it to you, but I just want to point this out. Nope, did that one.
That's right.
Hold on. We kinda did that. That's the only concepts we have not covered yet. On this proficiency scale. Those are the only things we have not covered yet. So you need to make sure you study, ask questions about those other things. The vocabulary is the key though. Guys, if you understand your vocabulary, Dewan, I need you focused. If you understand your vocabulary, all of this is very straightforward. Julian, you good? Okay.
Leave him alone. Leave him alone.
So, make whatever notes you need to, ask the questions you need to, but we need to cover a few more things today. We've got 35 more minutes.
35.
Yeah, y'all want to come, guys, leave Ariana alone and pay attention. Y'all ain't throwing stuff across my classroom or handing stuff to each other, because we're learning.
Yeah.
Alright, so, go ahead and get your notes out, or the textbook pages. We're not going to do a ton of notes right here, but get the textbook pages out. This is from lesson 1 with power functions. And I just want to remind you that we did talk about something with these power functions yesterday. This was a pattern that we noticed. Without drawing out a graph, so actually let me, hold on, don't go that far. Oh yeah,
Otherwise, it's way past that. M3-13, right?
what page?
M3-13.
Yes, M3-13 is where we are. Kyson, you got M3-13 out?
I ain't read the pages out.
Then come get a textbook and read those pages out.
You say M1.
M3-13. Okay. Does anyone remember the pattern that we discovered yesterday with these power functions if they're going to be invertible?
The even degrees weren't the same.
The even degrees were not invertible, and the odd degrees were. So, let's check that. This is what, if you graph it on the calculator, this is what y equals x to the 4th looks like. Nope. This is what y equals x to the 5th looks like. M3-13.
Oh, you want us to write these up? Great.
No, I just want us to notice this.
So don't write these in one?
I mean, you can sketch them really quickly and just make a note here, but just, is Nate's prediction that the even degrees are not invertible, but the odd degrees are invertible? Is that prediction correct? Was that a pattern we saw yesterday?
Yeah.
Right? So, even degree power functions. So, not invertible. Odd degree power functions are. So, do notice, are these originals functions? Yes, they're just not what? Invertible. Their reflections across y equals x are not functions. Yes. So the only real difference between the first and the third is that this one is going to be a little less flat in here, and this one's going to be a little bit more flat in here. Because remember, how many zeros does this one have? 4. It's x to the 4th, so it's going to have 4 zeros right here. That's the only zero it has, so it has a multiplicity of 4. This one has how many zeros? 6. So it's going to have a multiplicity of 6 here, so it's going to be a little bit flatter. I'm not going to test you on that, Chandler, but that is a good question to ask. The priority is recognizing odd or even degree power functions are not invertible, while even odd degree power functions are. Okay? But it's just because there's a higher multiplicity here, it flattens out. The higher the multiplicity, the flatter it gets. It's not flat, but it does get closer to being flat. Okay? It does. If you were to look at y equals x cubed, y equals x cubed looks like this. See how that flattens out more than x cubed did? This is y equals x to the 5th. X to the 4th, x to the 5th, x to the 6th. The higher the multiplicity of that zero, the flatter it gets.
Somebody got it.
Alright. Is that right, DeJuan? It's good to know. Right here. So, notice right here in the textbook. Okay. Right here in the textbook, if you want to make these notes to yourself, on this page, it has what key vocabulary?
Function, invertible.
Invertible function and horizontal line test, right? We got invertible functions there. We've got horizontal line tests there. The last thing I'm really going to point out on this page is this. I mentioned this yesterday. What was that notation mean, F, with that superscripted -1? No, so prime was this. It's just like an apostrophe.
That's inverse.
So,
Nah, yeah.
right here. Its inverse is written this way. So this is the inverse of f of x. Okay? So Sean, what does this notation mean? Sean, it's written on the board, dude. It sure is. So, how would I read this? Not h of x.
Inverse of.
The inverse of h of x. As soon as it has that superscripted -1, it means the inverse. How would I read this? The inverse of g of x. And that's why when you get there, y'all have probably seen, hopefully in geometry, you saw this symbol, sine of x. You know what this is? The inverse of sine of x. That's it. That superscripted -1 means inverse, sir. This will be page 14, I believe. Yeah. Page 14 there.
Miss Kenny,
Ma'am,
can I go to the restroom?
better run like the wind bullseye because we gotta move with these last 30 minutes. Okay. So, if you move to lesson 2 in the note or the textbook pages. Bye. Okay, so moving to lesson 2, so page 19, then page 20.
Oh.
Notice what is page 20 having us do? It's the root of the matter, but what does it have us doing? So and how did they do that? What's the first thing they did? They transposed, and then what did they do? They what? So they took that square root, right? So we've already addressed this idea. Notice, page 20, right? So this is what we already put on our Frere model, that to find the inverse function, what do we do first? Transpose x and y, the inputs and the outputs, and then solve for y, okay? So, we just need to recognize that that's what they're telling us here.
But why would you solve for y, but why would you solve for
But if I was.
Well, we're looking at the inverse function, and we still need to graph the inverse as y equals something of x, yes. Chandler? Yeah.
And why would
Say again.
Right now? What's killing me? We gotta learn.
This is a trap.
Trap phone. Trap phone?
No.
The one, look live.
Somebody capped up there.
You gotta find your name on it.
You want it. Man, you crazy. They're like, wait.
I mean, if you need to go, you need to go, otherwise.
Come outside, it's different.
I would wait until you can learn this. Alright, so I will point this out that we're not drawing out my expo markers by drawing on paper, right, Dewan?
Huh?
We're drawing out my expo markers by drawing on paper.
So,
We talked about this earlier. Hey guys, what you doing over there to the left?
Look him.
On my phone.
Get put it up. Yeah, sheet paper, Alice, take some notes, ma'am. Hey, right here. Why, when we had this equation, right, we took the square root, we talked about this earlier, why did we have to put the positive and negative here?
Because we had splits.
Not because of transposing.
This can be negative and positive.
So when we take that square root, we've done this in the past, it could be a positive or a negative, right? Like, that's the idea.
Oh, I thought
Why
you
do we
were
need a
talking
positive and negative? Because we took the what?
about- I thought you were asking why we switched the X and the Y.
That's not that cute. But, we talked about this earlier, is that going to be a function, y equals positive negative square root of x?
No.
No. So you'll notice, right here, because one input's gonna have two outputs, right? Notice how we did not use the inverse function notation? To make it the function in inverse, can I have positive and negative? No. The inverse function of x, inverse of f of x would equal just the positive square root of x. We have to restrict that domain. So to have the actual inverse function, I cannot do the positive and the negative.
Oh, yeah.
Okay? So to have the inverse function,
What if I don't want the inverse function?
you do.
This is too much repetitive content.
Don't complain when I don't repeat.
No.
Need just positive square root of x. So the inverse is a
Inverse this, inverse that. Transpose that.
oh no, it's like math is these connected ideas and not just memorizing rules. It's like one concept is the foundation of everything else, and I always try to tie back to that foundation.
It's like, after I get out of school, I ain't gonna remember nothing about it.
That's the problem. That's why we moved from Algebra 1 and Algebra 2 and struggle when over half the class has been just Algebra 1.
When I'm say transpose outside of school. I said outside.
I ask you-
Okay.
But remember, my priority is not just teaching you math. I am trying to teach you how to think and how to use language to describe things through the context of mathematics. Learning is learning, and learning is valuable no matter what the context is.